Hello and welcome back to another episode of Getting into GiG-33. Welcome back, Sydney.
Hi, Sebastian.
And yesterday I think we did leave with the first beginnings of which parameters to pass here to describe based on what we really need as a bare minimum, along with some flexibility when it comes to how we associate commit IDs with names, which are essentially the basis for anything that git-describe does. And then the thing was how to make an assertion, because right now there's nothing that is being returned, and I think that's where we could continue today. Yeah.
Question before maybe, because we're specifically passing in this hash set basically from the outside. Is this something that would be part of describe, or is that something you specifically want to keep separate? Like associating hashes or commit IDs with tags.
Yeah, in libgit2, it's definitely part of it, because libgit2 and Git, for that matter, they have full access to the repository. And we don't have that. We kind of limit access to the bare minimum and leave everything else to other people. This makes it easier actually to implement it, because you don't have to deal with options that, handle which names to provide. Branches, tags, annotated tags. This is what libgit2, for example, deals with in its option. I think you don't need it to implement the algorithm. So that's why I keep this low level, and then on Git repository level, you would have the options to configure. I suppose. And there's this trade-off between where do you want to put the comfort? Do you want to have comfortable things on the lower plumbing crate, or do you want to have it on the Git repository crate? But what I noticed is, that, it's a great question. I mean, I can talk myself into thinking, let's make it git-describe like everybody would expect it, so people can use it like that already. But then you have to provide access to the ref database, like git ref. And there is currently no general way of doing this. There's no trait for that. There's just one database that is the standard ref database. But there might be ref table one day, so you have to kind of hard code it to one particular type. Or you make your own trait, which we could also do. Make your trait here, which allows you to access something that could be a hash map. But then it's so, it feels a bit over-engineered. Like you spend time on having a trait for a hash map, which we could also just make a hash map, because there are standard types for that. And we are okay using the standard library of Rust, because just the standard way. But yeah, I'd start with that, let's say. And
exactly, it's the easiest way, the most obvious way to start with, and then it can always be optimized later if the need arises.
Yeah, optimized, or let's say change towards some more comfort in the plumbing crate here. Okay. Now we have a result, and we want to make some assertion on the result, which in this case would be right. So here, this name main is directly on top of our commit ID that we pass in. So that will always be the name itself that we return. So now it's just a question what kind of data structure that is supposed to be. I really don't know.
Yeah, what are we returning?
It can probably fail. I mean, I know that much. But that's it.
And from, the final goal would be to construct that string that we see in the command line, right? That is basically what should come out of there.
Yes.
And I don't know if it needs to be, like, I don't know what is easier, to construct the string directly in the describe method, or to have some sort of data structure that has all the necessary data and then, split it up in that way, that it basically formats itself.
Let's see. What would libgit2 do? And they do return, they return an int, get name data. Interesting. I think the name data, that might be the thing that contains the information. Describe option, describe result. Look at that. Okay, that's what we're looking for. Ooh. That's interesting, huh? Type def struct, type git-describe result is a git-describe result. It looks like it's the same thing. But where's the actual definition? Is this a way of for declaring the structure and then it's actually declared somewhere else? I do not know. Like, how does it access this? So there is something on it. There is a repo. Here's the describe result. So that's kind of a forward declaration apparently. And here, that comes out of that.
Okay.
Commit name. Possible tag, I don't know what that is. Fallback to ID, exact match, dirty. I would expect the number. I would expect the distance to the tag. But that's a type here. Possible tag, so that has data. And there we go. Depth. Okay.
Okay.
So that's probably the commit ID that comes behind the G. That is the actual ID that was passed. So we can make that part of the formatting, I suppose. So it's kind of copied here. Okay.
Mm-hmm.
Whether or not it's an exact match. Dirtiness, that's something we don't support right now at all. And that, knowing that, but that's up to you. I mean, we probably want to be able to format the whole thing like it should be, even though we might not be able to set all the, or know all the data. This is just a flag in a way, right? It's whether it's dirty or not, and then there's a suffix or not.
Yeah, so we can implement the functionality, you mean, but it's whether it's being set, that's just not supported yet.
Yeah, like we can implement the formatting, I suppose. I also have never really seen how Git does it. Git revision, tests, fixtures. Okay. Git-describe. Okay. And now I make it dirty. Not dirty enough. Yeah, there's not a single file in that repository. And maybe there's also some way. Dirty mark, append mark on dirty working tree, default dash dirty. Okay. So I think the problem might be that it needs to be here. No. With commit tissues. Okay. Okay. Yeah. Now we have dirty.
So untracked doesn't count. It's just not committed yet.
True. Untracked doesn't count, but anything else would probably count. Then we have a dash dirty appended to it. Yeah, but that's it. We don't even have to do that. It's just a flag, right? It's so simple. I would not make this part of the scribe. There isn't anything to do with that. But yeah. So data structure. I mean, we can go in and define the data structure right here. So we know it's a result. Okay.
And then we would have some newly defined struct, right? Something like, I mean, they call it get name results. Yeah.
That's the
easy.
good thing about how do you call it, conventions, and that's just my convention. Then you don't have to think.
Exactly.
Yeah, makes sense. Some at least. And we are implementing the function. So mod describe, it's a pub mod, we know that much too. And now the outcome. Okay.
So so we include the dirtiness right now, or we just keep it in there.
Yeah, I mean, describe. Yeah, I mean, this thing should be able to format itself. We want to generate a string from that.
Mm-hmm.
And this means we do have to implement display for it. Okay. And to display the dirtiness, you would have to know the suffix to use. So this is why.
Oh, because that can be configured.
Yeah.
Okay.
That's why is dirty bool doesn't really help that much, because then we would still need to know what to say.
So you could have it as an option, you mean? Just dirty suffix and then optional string.
Mm-hmm. Let's just do it like this. Owning things makes stuff easy. We could also say you can borrow it, or you can make it a cow. That's typically the options here. I'd not over engineer it, given it's just a suffix and it's just one string, and it's fine. It's
Sure.
gonna be fine.
Mm-hmm.
No need to optimize anything here. Okay, dirty suffix.
Yeah, I mean they have another flag there which indicates if it's the first one, right? Exact match. Yeah. I would assume that this means if the commit is, yeah, if it's the first thing you're looking for, basically.
What about the depth?
Yeah, I was just about to say, I don't think we need that, right? Because we can track that via the count of how far away it is, maybe.
I think so too. Like, I would believe there's no reason for Git to ever say something like dash null or dash zero.
Mm-hmm.
Like dash zero.
I think it even says in the manual that if that is the case, it just uses the tag itself.
Okay, great. Then I think exact match checking, there is no need, not like this.
Mm-hmm.
Okay, depth.
And then, yeah, the other parts are, I guess, yeah, at least the ID, right? The OID we need.
Mm-hmm. The object ID for the suffix, and then we need a name.
And we need a name. And yeah, exactly. This is just the tag name. Mm-hmm. This will be the one that we look up, that will be found.
Mm-hmm. It's not necessarily tag name. This is why I don't call it tag name. It could be a branch as well. And we do have cows here as input, and we just keep exactly the same thing, which also means that we get a lifetime here. That's fine, because now we have to either say static, and a static cow, that means it's always owned, or you have a static string in there which is known at compile time. That's also possible, but that would not be compatible with this, which is any lifetime. So here we have to introduce a named lifetime. Like this.
So again, the cow, because I don't necessarily know what that does. It just decides at runtime if the value is owned or referenced.
Yes. Look at this.
Okay.
It's an enum. You can write it yourself.
Right.
There's nothing magical, fortunately. There's one special thing because it needs the type to implement to own. This means the type itself knows how it's borrowed and how it looks like owned. And the types we use here, they know that, like bstring and bstr and bstring, because it does want to convert back and forth. It needs to be able to do that. But yeah, it's just an enum. And one part of the enum has the borrowed version here, see? And the other part
explaining the lifetime
has the owned one. And thanks to toOwned, looking at the borrowed version, it knows the owned version. This is why you always provide the borrowed one along with the lifetime instead of the owned one, which could be just as correct, right? Then you have to get the borrowed one from the owned one, but that's not how the Rust traits are made. Just the other way around. Yeah.
And then in the implementation, you actually have to handle both cases. Like you have to look at the borrowed and the owned case.
No, because what you want usually in order to, like first of all, we don't care about names at all. Like we don't look at them. We just look at the hash, at the object ID and see what name comes out. And we literally just drop it there and say, cool, thank you. And we don't care if it's owned or not. But if you were to do something with that name, you can just say, okay, I would like to work with the reference to the value, which is always the borrowed version. And you can see how if it's borrowed, that's just it. And if it's owned, you can always get the borrowed version from an owned one too. So that's the common denominator in case of a cow. And you would just work with the borrowed version of that.
Okay.
And yeah, that's really neat.
It is.
And really the only reason we have a cow here in the first place is that I say, okay, what if you have 100,000 names to look at? And that's the reason. Otherwise I would just go with bstring owned and you're done. And not introduce lifetimes, but maybe there I'm predicting the future, which is kind of always an error. Okay. But that looks pretty good.
Yeah.
And then the describe error. Let's just go with some type def for now. That gives us the type and we figure out what that detail would be later. We do have quick error at our disposal here and can just use it. Yeah, great. Let's compile that. And oh yeah, needs a lifetime here. And now, yeah, lifetimes. Expected a lifetime.
Oh, of course.
Parameter. Yeah. Why of course?
Well, I mean, you're describing, you're defining the struct with a lifetime above, so you have to specify one here.
But why? Why can't it automatically decide which one to use? Like, why can't the Rust compile?
Yeah, because now, yeah, well, you have two input references, right? I think that is the reason that it can't automatically know which one you want to use.
True. It could be smart, right? It could be super smart and say, look, that's the type here. It knows.
Yeah.
It kind of knows which type is supposed to be that one, so it knows that one should be it. But it's not really doing that. It's fair, I guess. Better be explicit than implicit, because that can just implicitly change by changing the signature, and then weird stuff happens and there's breakage and people might not even notice it. Okay. Now, does it compile? It does. fields I never read. Yeah, we want to make them public, I suppose. Like, can we make them public? Or do we have to hide them?
Yeah, I think at least the depth would have to be public, right? Because that is... No, actually, all of them have to be public.
I mean, that makes
Because
the
you
warning
would-
go away. That's good. But why do they have to be public? Do they really have to be public? I mean, if you would use them, the warning would also go away. But if they are public, then there is no warning of being unused anymore.
So I'm just thinking ahead now, like how you would fill these values in the traversal. And I'm guessing the depth is something that you would... okay, I guess it depends again. So you could write this outcome once you're done with the traversal, right? Then you could just have a constructor function.
Mm-hmm.
And then you wouldn't have to have any of these public because the formatting is done on the type itself. Or you initialize the type before the traversal and then kind of fill it up while we traverse, or kind of mutate values.
Mm-hmm.
Not sure which one is better.
Yeah, you think in terms of how do we access the data while filling it? That's not how I think at all, because we are very close to that type anyway. We can probably make it work so that we can keep it hidden, like with pub crate or something, and then it's not really public, but you can still access it without problem. So the question I have really is it okay to make it public for everybody to read it? Is it just stupid data, or is there some invariance between these fields that have to be matched so that, you know, no strange things happen, for example, during formatting? And my answer to this would be, it's safe. They can all be public. Users can change these at will, and they will always get something reasonable because there's always an object ID and the name is always associated to. So it's really just the question of whether it's an exact match or not, depending on the depth, and whether there is or whether there is not a dirty suffix. And that's pretty much it. So yeah, you will always get something reasonable, I think. So now what? Oh yeah, binary operation is not supported. We don't implement equality. Derive partial equal on the t ord partial ord, the typical things. Yeah, that's always a bit annoying. I usually copy paste this and then I don't remember where I would copy it from. Is there some, because I'm pretty sure that many types still kind of miss that, or they just have the bare minimum of stuff. Yeah, probably not this one. Derive a long one like this one. And that also has serialization and so on. That's kind of a boilerplate. SERDI support is usually coming in as an optional feature. And this is why you need to protect it with the config adder, saying that if you have SERD1 defined as a feature when building, then we can use these traits to auto implement serialize and deserialize, which then allows us to use SERD to serialize and deserialize this structure to all kinds of formats. And that's the typical stuff you want to add to be a good citizen in the Rust ecosystem, so that you can do all kinds of things with that data structure, whether you think it's useful or not. So I can just copy paste this here. Only clone, that's good. The rest should be fine. And then the question, should you do SERDI or not?
So yeah, okay. So this is just to be compatible if other people use this, basically. You want to be as nice as possible.
Yeah, we just need these two. But having debug is also nice to have for sure. It's another form of serialization, and this affects your binary size. It's really just added code everywhere. Even though it gets auto-generated, it's weighing in. but it's kind of the default, so you just do it and don't think about it too much. Whereas this is special and it's usually a bit annoying because now, at least the first time, right, with these little crates, you have to now set this up, add a feature, and then not forget to activate 30 for all the other ones. So you see how this is kind of coming from bstring as well, which does the same thing. Then we can say git hash 30 should be activated, and then git object 30 should be activated. So, oh, this should be activated. Hash bstring. Bstring we don't have ourselves, so that can go away. And 30 we still need. With a particular setup here. So you see how I copy paste this to just get the right thing, default features. We just want derive, so to keep this small, even if it's activated. Okay, but now the boilerplate is done, and we should be able to get a bit further when compiling. Now we want to compile outcome. Okay, what's the outcome here? Describe outcome. So useful to have these, have it automatically write all the fields for you. Then name is main. It's actually exactly the same thing. Oh, interesting. Will it move? Will name move in there? Or is it copy? This cow should implement copy, but I don't think it does because it also could be owned, and if it's owned, then it's not copy anymore. So I think this does not work because it's moved. Fair enough.
Oh.
But it could, because that's just a reference, right? But because we put it into a cow, you know that the clone is going to be cheap, so we just clone it without thinking too much about it. Okay, I think about it, but I know it's cheap. Not that it matters, but you know, I always think about that. It just happens to you. Then the commit is that. Oh no, wait, the commit ID, right? And that is copy, fortunately. Depth is null, 0. And there's no suffix, so that's what we would want. Okay, cool. And now as I actually run this, it will of course fail. We know that because it's not implemented. But that's cool because now we do have a full method or full function signature here. That's exactly what we wanted. Okay, so I thought to have some feeling of success, we could just implement the simple thing first, which is the formatting. Just
yeah, I was about to say the same. For jumping into traversal stuff, the formatting.
Yeah, do everything else, literally. Clean your room if you have to. That's what I find myself doing sometimes. It's cool. That's the way. Always have things that you like to do less, just to be rewarded when you finally do them and you see, it's actually not that bad. Slowly ease in. All right, the test. Yeah, it's a fully open data structure. So we are in describe mod. I'm just trying to find a good place. Describe mod, describe outcome, format.
Yeah.
We could call it outcome, format even. And then, yeah, exact match. So basically what we would have here, we can just implement this, which also allows me to copy paste that. Insert equal. Nope. Import that, please. Okay, there. Insert equal to string is, what's name? Carl borrowed main as bstring. And that ID can just be any hex to ID that we find somewhere, maybe a bit more complicated than 000. Okay, B92 something something. Depth is 0. Maybe I would also want to assert that the outcome is an exact match, which is also something that people might find interesting to query, maybe, because I'm just thinking this because of libgit2, which makes this a flag here. And I just think, yeah, they probably have a reason to do that. And yeah, I just trust their experience and say, especially since we have this special idea of depth null equals exact match, right? Let's make it obvious.
Very true.
So that should be true here. And then, yeah, what would that be?
Is it just main, or is there something else?
I think it's main. Speaking of, since the object ID doesn't matter, we could also just go
Default?
Oh, I can't. Interesting. I thought I could. No, that's how we do it. I can't do it the other way around. I have to do. See, I just wanted to invent a nice API that allows me to get this real quick. And that maybe is something I just quickly do. Why not? Because it makes sense. If I want that. There's not too much implemented here. Impl kind. There we go. Impl kind. Longest, shortest. Yeah, why don't you give me? No. And since this is copy, we can just do it like this. Oh, it doesn't like it because duplicate definition. That's unexpected. Previous definition here. Oh, I already do that. Really? Oh, interesting. But why did it not complete? IntelliJ did not tell me that this exists. Okay. It's also a const function, so yeah, fine. Nothing has to be done here. Okay. Right. Because you have to do like this. That's a value. Now I instantiated it. We can't just consider it as a namespace.
Okay.
That was me. Okay. Oh yeah, like this. Yeah, and that should all be true. Let's make that method happen. Also very useful, create method. And in this simple case, it did just the right thing with everything, all the boilerplate with the lifetime. I just couldn't figure out what the return value should be because of the macro. Yeah, that's that.
Should be it, right? Yeah.
Should be right. Even if it's not, our test would tell us. And now for the toString part. Not yet implemented. There was some build error that is already gone. Build warning. How can I get back to this because it switches windows? I don't know. Okay, whatever. The build warning we can just ignore for now.
It'll come back.
We'll probably come back some other day. Okay. Yeah, toString, by the way, that's a way to trigger display. Like you can run format yourself in some shape or form. So format will just call display as well and produces a string. But toString does just the same thing, but a bit differently, like creating the formatter itself and attaching it to a buffer, and then it writes directly into the string displaying itself. So panic message is not a string literal. Oh yeah, right. Assert equal. It's not a message. Good. Cool. Now we're here. Can implement this.
Yeah. I guess that would be another if statement, right? If it's an exact match, then we have a simple case. Otherwise, to do.
Yeah. Let's make it like this. Then we dog food our own function. And here it's, so we can call some function on this one. So just, you know, I had to learn this. So maybe we've done probably this not for the first time, but maybe it is the first time we actually implement this. Is it, or is it not?
I think we've done like a really quick one in the past, but yeah, I would have forgotten how the format works. So good refresher.
All right, then quick refresher. As a baseline, you can always use the write macro or write line macro with the formatter as input. And then you can just basically do what you want and use all the formatting and, you know, all these format thingies that you have and do fancy stuff with it. But that's also the most expensive. And we could use this here and just say self name should be formatted with that, and that would be fine. That would work. But you can imagine that this write macro expands to creating an argument list and then stuff. Even though it's very simple, it's additional work that happens for nothing really. Because all we want is to say we write a string, right? And this formatter has a bunch of capabilities that we can just call and use directly, as well as a bunch of options and other capabilities.
Pretty cool.
Like alternate, like the Boolean, like everything that you can do with the formatting syntax that is used in these macros is something that you can query here in the formatter, because somebody might call you from one of these macros, so it passes on this information to you, and you can actually respect that and then format it accordingly. But in our case, all we want to do is write ourselves as string. Gotcha. We've got a cow with a B string, but not a string.
Well, as ref, as string, as ref.
As ref, now we have the B string, which is really just a bunch of bytes, whereas str requires UTF-8 encoding. So the good thing is bstring can do that for us. It can actually automatically display itself with the formatter and then handles all the decoding issues itself. Like it can fill in invalid UTF-8 with a question mark character or something like that with these replacement characters. This is one of the capabilities of bstring. You can use it as a string even though it's just a bunch of bytes and it's not really assuming UTF-8, but it prints itself as UTF-8 if you ask it. So how do we ask it? Like write string doesn't work, but we said this implements display, so we should be able to just do that.
I mean, I know, yeah, you can always create a new string, right? But I guess there's an easier way if you say the formatter itself implements it.
Yeah, look, like we implement the straight display. This means we have a method, we get a method that is called fmt, takes a formatter. And if name implements display just by itself, you can just call fmt on it and do this, right? And then we hand it over. And that should just work like that. You can do everything you said you can do, like convert it to a string, call to string on name and do all these things, but then you basically implement fmt yourself. And you wouldn't want that. See how the cow just forwards the same thing, but it has a different call mechanism here. It just says, oh, I want this trait, and then as a first argument I pass my referenced my borrowed thing. So yeah, pretty neat. This is old syntax, by the way. I mean, you can still use that, but nobody does that anymore because now it's automatic. And I think here, like, no, nobody writes it like this anymore. Not really. It's like here you consume yourself because you dereference yourself, so that's now owned. And in here, in order not to actually consume yourself, you take a reference of your content. And this is how you have a single reference here and not a double reference or something like that. Borrow. And this is why this syntax exists. But nowadays you can just, you can just remove this and do nothing. You know, you can do nothing special. You just write it the way you think you would. Match self, borrow B, and then it is just the right thing automatically. But that's older. By the way, I think they would, I don't know, do they accept PRs to fix this kind of stuff? I think they would, so probably an easy way to get your name into the Rust compiler. I contributed to the Rust compiler. That's possible. Oh yeah, the test is green. I didn't notice.
Oh, it's already run. Nice.
Test works, cool. Exact match. Then let's have this one. Exact match dirty.
Yeah, okay.
Yeah. Everything remains the same. We just put a dirty suffix here. Yeah, let's just test this here. I feel a bit too lazy to copy paste all of this. Doesn't seem worth it. So dirty suffix now is some dirty. And now we would expect that. And it doesn't work, okay.
Okay, yeah, I just thought about if you want to put this into a tuple match, but I think that doesn't really make sense. Oh, you could, yeah, maybe match on both at the same time without it being nested, I mean, but it might be easier to write this way.
Yeah, it's a nice idea, by the way, to think of tupling these up right away. And then you have it with or without, but that gives so much importance to the dirty suffix. You know, it's really just something you put at the end. Maybe we can handle it that way because it's always at the end. So if let some suffix is there, then we just put some stuff at the end, literally, right? That makes sense. But it's interesting. I had the same intuition, like put stuff here, because that's where we are looking at right now, like very, very focused, laser focused. But that's maybe not usually what we want. But that also means we have to do this here because we can now go through. Then we have an OK here. And we are back in business. That should not be owned. We don't want to take that out. And then, yeah, paint two things, huh? FNT right string, F right string dash, and then.
Oh, okay. Yeah, I was just wondering how this works. So you can, the formatter is just a buffer that you fill up, so you can reuse it. Okay.
Yeah, true. It's just that you've seen it, huh? How it's created for toString, just associated with a buffer or writer. And now we can just keep doing stuff to it. And of course, we could just have our own format string in here and just use that if it's more convenient. I just choose to write it out by hand to get the best possible performance for writing describes. No, but probably, you know, like you can do that, but no, not write line, never. But probably it's easier to just do this and say, screw it. That's fine.
Super easy to read, yeah.
Easier to read than the other stuff, huh? But you could. Okay. But I like this because now we know nothing else seems to be important. If you have an exact match, then it's really just that. Oh, is it? Only output exact matches? Ah, here, that's the most recent text that should be considered. That's the same thing as in libgit too. Exclude, so all this is just about the set of things. Show abbreviated commit object as fallback.
Okay.
Yeah, that's something we can't really do yet. Okay, so really if there is nothing, it just does this as fallback. We can't do this as part of the outcome, but it's something we can consider as part of the API. Like what should be an error? You know, should it be an error that we didn't find anything, or is there an option that says, okay, we can represent that there is no name. And if you could represent that here, then we can make it a non-error or something. And then we might even say there is no error. Maybe there is no possible error, but maybe there is. Probably there is. During traversal, there might be an error, for example. So we have some errors that are probably hard errors, but others might be soft. And just a question on how to do this. I would actually, you know, it's not that we have to change this now. It's more like I would lean towards making this optional. And then we just by default fall back and we allow nothing to be found. And somebody has to then check that, you know, has to validate it. So the one implementing this program here would then have to see, oh, is there a name at all? If not, I need the always flag to actually print something. Otherwise, I call that an error. So they kind of have to upgrade the outcome as to an error. Anyway, right now we don't have it. Right. Need this. So you see I can just use the format as a buffer. And it works again. But back to the original question, I think
Yeah, whatever that means.
yeah, libgit2 doesn't have it. Must be very special. I just want to see if there's a way to get the abbreviation always. So name, because main can move around, like main doesn't tell me much.
What is long format? I mean, does that expand it? Yeah.
Oh, now I see. See this?
Oh yeah, okay, they do have it, yeah.
Okay.
Okay.
Cool. So that tells us something. So we do need a flag, huh? And we need to know if you should display the long format or not.
Yeah, but this would be the only flag that we need, right? If we have the display long format flag, I don't think we need the is exact match flag.
Right. Great. That's true. So if it should be long, then we always display the real deal.
Yeah, and this is the only case this would be useful, right? So if you have an exact match, that's the only case where it's not in the long format by default. Maybe.
Yes. Yeah. I think so. By default, it's short format, but only it's short if there is a non-exact. Short is only there if there's an exact match. Yeah, if depth is 0.
Yeah. Mm-hmm.
I think so, yeah. Cool, look what I'm doing here. I have a field named long and I have a method named long. The method is consuming and outputs itself after it's changed itself to long. And I also want short.
Oh, okay.
Because now we can just use this very convenient API. So it starts out short, and then we say long, and now it's long, and returns itself. Oh, but it's consuming, so it moves out of, yeah, can't do that then. Not like this anyway, I was going
So you
too
can't
far.
reuse the outcome, basically. Mm-hmm.
Yeah, but I can return myself as that. So now I can print myself still. Could even return myself as immutable if I wanted to, but we can stay immutable, why not? And now I should be able to do this. And that should now be what? Now I also need more than just null sha, I suppose. Oh yeah, what's the hex length going to be? We need that pre-configured, we need to know that. Are you still there? Ooh.
And we're back.
Welcome back. Here, I was about to say, now we need more than a null sha, I suppose.
Right. Mm-hmm.
to make it a bit more interesting. Okay, there we go. But we also need to know about the abbreviation length, or the length of the short ID. We don't have any means of figuring that one out. Somebody has to provide that. So how do we call it here? Hexlang. Yeah, look how that gets more complicated now. But it's fair. I mean, hexlang is literally the prefix plus hexlang. We could put a prefix here even.
Yeah, as those combined, actually, yeah.
But then again, it's less flexible. Like, people can change the hexlang and get different versions of it. They would probably like, how would you use that? Like, in order to figure out the hexlang, you would probably get a short ID first, and short ID gives you, what does short ID give you? Short ID gives you a git hash prefix. Ha. But also in order to, yeah, no, I think it's two separate things. We would need the hexlang, and that's the input ID that we got that we should describe. That's always the input ID. So yeah, just need a hexlang. And the hexlang now could be too long or too short, even. Again, even though there might be no too short, honestly, because we just format it accordingly, and we just handle the case that it might be too long and just make it happen. Like, for formatting, this is where we are flexible. We just display as much or as little as we are told, and that's it. Because that's plumbing here. I would see it like this here.
Okay.
And, you know, just for user display. If you format it incorrectly, yeah, should be fine. Should be fine. Then back to describe. Okay, that blew up in complexity real quick. But yeah, now we have to do everything just with this example, you know. So this is 7, huh? B920 BBB. And we have
That
node
should do it, yeah.
30, yeah. Okay, so that's the short one, and that's the long one. And now we set the dirty suffix, and we should probably, and we can try out the short function here. Oops. Okay, and that should be main dirty. And the long one is this one, huh? Yeah. Yeah, just checking again. Yeah, that looks reasonable. And the name, of course, you know, that's heads main here. This is also interesting because now we have to, like, somebody has to find names that are unambiguous. And that's something we just don't do. You know, we can put anything here, literally, and that's going to be fine for us. So somehow long form also gives us heads main. Okay, it still gives us heads main, which I find interesting. Probably it says heads main to differentiate it from tag names, because tag names are just names, and if it's a branch, it puts heads first so that we know it's a branch. I think this is why it does that. Yeah, but that's probably what Git repository then has to do. Git repository implements this and deals with all the nitty-gritty details of naming things correctly. Yeah, let's maybe that can be quickly implemented. Oh, hex. Yeah, right. Hexlang, where does it come from? And long.
Yeah.
Long can be default to false, I think. That would be fine. So we can just put this here. But hexlang, where is that coming from? Like this? Oh, sorry, not like this. Like this.
Yeah, I guess you would have to pass it in. Just I don't think there's another way.
Yeah. Yeah, I think so. Huh. Okay. And now for the implementation. Oh, wait. Yeah, so only in short mode we want to do this. Otherwise we go here and the rest should be fine. That's always a suffix. Yeah, the rest should be fine. This means now we just put the depth there and the
Main depth,
the G suffix.
prefix and yeah.
Okay. So let's keep it simple. Depth dash G and then the hex display, self depth and self ID to hex with lang. Self hex lang. And that does just the right thing.
And you still need to put in the main, right? Because we haven't. Yeah.
Right. The name is only the first thing we do. That's the kind of shortcut we take here. But I think it's fine to just format the name. And now we see the whole format as long format. Yeah. Maybe. Test the screen. It's not really exact match anymore. Exact match with dirty and long format. Yeah. And now for fun, maybe a non-exact match. Okay. Now the only thing we can really change here is the depth to some other value. And there's not so much we can do either. It's really kind of boring. Like, it's kind of the same thing, but with a depth.
Yeah.
Yeah. I tend to say, since we know it's kind of the same thing, and we test short and long so nicely here. Yeah.
That's pretty much all we need to do, I think. Yeah.
That's all we need to do. One nicely condensed test. And maybe, you know, just so that I've seen it, outcome depth is 42. And now show me that the short version now, the version by now should be the right one. This is something we didn't test. So that's now 42. And the dirty, maybe even can put that away. Okay. Maybe now I edit again. Then I want the same one again. And maybe the long one again, and they're both the same. Something like that. Just so that I exercise a bit more of the flag combinations.
Yeah, just to make sure.
Yeah, it works. It's never super awesome to see that it just works. But I trust it. We don't fake it. We do the real thing. And there isn't so much happening here. Yeah. The only thing we can't really do yet is the short, like this special case here, which is always show the abbreviated commit as fallback, which seems reasonable to have. Like if I can't find any tag in the past, then show an abbreviated commit. But
yeah, but like you said, is that part of the formatting, or is that part of the input handling of the application that's using this function?
Yeah, we're quite plumbing level here right now, huh? With the hash set and so on. So I'd say the caller has to deal with it. And we can just return an error or an option. Right, if we don't find anything, we could encode the non-existence of stuff as an option. And then it's really easy to deal with errors correctly, but also quickly swap in something that is just the ID itself as prefix, for example, as short ID that we display instead. So I think this is what you would need to do this nicely.
Although, oh yeah, okay, no, actually, if you do this in an option, then you wouldn't know the ID in the first place, right? Because we're returning none if we don't have a.
But we know the ID.
Outcome.
We know the ID. It's always this one, right? Like this one is always the one that is displayed behind the G.
You're right.
The caller knows it, so should be fine. The only thing we really find here is some arbitrary depth that will be hard to understand for many. This one here, and a name of the closest tag or annotated tag or branch. And that's it. That's the two things we find. And everything else is known by the caller. Dirtiness and or ID. Yeah. You are quiet, which means that maybe it doesn't make sense to do that. Or yeah, do you hear me? You are muted. But
sorry. I hear you.
You were awfully quiet. Is this something you can go with, or am I missing something fundamentally here?
No, I think it's fine. I think I was just confused about the. I thought we had to find the ID as well, but yes, if this is something the caller knows, then that's perfectly fine.
Yeah, but you still say if it's something the caller knows. I think it is. Like, if we do this long git ref parse head, it's always the current commit that we display.
Mm-hmm. Yeah, I thought it was the one
At
where
the
we
tab.
found the name, but yeah, I guess then this makes a lot more sense as well.
I think you think it's where we find the name because we at some point compare some commit with the commit at which the name is located.
Yeah.
And
but this is just because when we parse the commits, right, the parent, it shows it as a hash, so we have to make that association.
Yeah, it shows it as a hash, and we want to know once we found a name in the history of that commit that we actually want to describe. And then we just know that we found a name, and we can eventually abort based on some algorithm that we still have to write. But yeah, that looks great. And the formatting is already done.
Coming together.
Yeah, it's coming together neatly. As expected, at least with the formatting. I do like compared, right? Like what libgit2 does and what we do to make this work. It looks really clean because we have such a laser focus on one particular aspect that is nicely isolated, and you write a bunch of tests, and that's so easy to develop then, and it really just works. It's as easy as it looks like, so to say. Whereas it's not so easy to figure out where this stuff is in libgit2, for instance, and there seems to be more complexity with pointers here and pointers there. There's a repo pointer for stuff, and that's the thing. Like, you put all the stuff inside to be able to support certain features, even though maybe you don't want that, all these dependencies in there that kind of detract you from what you really should do and what really matters. And layer, compose your application by putting layer and layer and layer on top, instead of just having this one big furry ball with stuff and then try to change something. And it's like, it's stuck. And I think that's a huge advantage here, both when developing it, but when using it, and when maintaining it into the future. Yes. Cool. I think that's a nice finishing point for today. Thanks a lot for watching, and have a nice day. Bye-bye.